I welcome everyone for this video lecture. In this video lecture, we are going to discuss about schedules in transaction management. Types of schedule: serial schedule, non-serial schedule, recoverable schedule, non-recoverable schedule, cascadeless schedule, and strict schedule. So, as the name consider, we start with the serial schedule. It is a serial execution, that is one after another. Consider a schedule with two transactions T1 and T2. You can have a three steps of transaction in T1 and as well as T2. Read of A equal to A plus 100, write of A. So after the execution of T1, we will move to the T2. Read of A plus A equal to A plus 500, write of A. So the T1 will be executed after T2. So that is given as the serial schedule as is T2 is executed after the completion of T1 completes the execution. So once the T1 completes the execution, then only T2 will be completed. So where it is a next one is a non-serial schedule. A schedule is non-serial if the operation of transaction the schedules are interleaved. Consider the schedule with same two transactions T1 and T2. You can see here read of A equal to A plus 100. Again when we can go for T2 read of A, when we will come back to T1 and write of A, here it is completely over of T1. Then again we go for T2 A equal to A plus 500 write of A. It is a non-serial because the operation of T1 and T2 are interleaved. That is completely T1 is not executed and completely T2 is not executed. T1 is executed parallelly, T2 has one set of instruction. T2 will be executed parallelly which has some set of instruction in T1. Next one is a recoverable schedule. A schedule S is a recoverable if for each pair of transaction T1 and T2 such that T2 reads a data item previously written by T1 and commit operation of T1 appears before the commit operation of T2. So consider the two schedules at T1 and T2. You can see read of A equal to A plus 100, write of A, commit. Then we come for T2, read of A equal to A plus 500, write of A, commit. So in this schedule, T2 reads the value of A updated by T1 because initially A will be 100. With that A 100 can be taken as T2. So end of the result what will be in write of A? 600 will be in write of A. So in case if T2 is saved from the rollback due to the failure of T1, thus this is a recoverable schedule. T1 A equal to 100 will be stored. So the data of T1 can be recovered. Next one is a non-recoverable schedule. That is, S is considered as a non-recoverable schedule for which each pair of transaction T1 and T2 such that T2 reads the data item previously written by T1 and commit operation of T2 appears before the commit operation of T2. You can see the diagram. Read of A equal to A plus 500, write of A. Then it is there, it is not committed at T1. It comes to the T2 and again it will go for some transaction. Initially consider A equal to 0. After T1 executes A equal to 100, then it comes for 100 plus 500 in T2 and at last it got committed. So if there is some set of failure in T2, the data cannot be recoverable because at last after the commit abort, the transaction has been ended. So this we call it as a non-recoverable schedule. Whereas in the last schedule recoverable, we can see that the data can be recovered because we are using commit in T1 and T2. Next one is cascading rollback and cascadeless schedule. Even if a schedule is recoverable, to recover correctly from the failure of TI, we may have to roll back to the several transactions. That is, in the case if we are not giving a commit or it is not, if we are going to recover, we have to roll back to the transaction. Consider a schedule with three transactions T1, T2, T3. You can check in transaction T1 writes the value of A, that is read by T2, and T2 writes the value of A, that is read by T3. Suppose at point T1 fails, T1 must be rolled back. Since T2 is dependent on T1 and T2 must be rolled back. Whereas T3 is dependent on both T2 and T3 must be rolled back. This is a phenomena in which a single transaction failure leads to the series of transaction rollbacks. It is called as cascading rollback. We will be rollbacking for the recoverable schedules. Next one is a cascadeless schedule. This is same as cascading rollback is undesirable since it leads to undoing of significant amount of work. You can see here there is only no commit in this T1, T2, T3. Here you can see there is a commit in T1 and T2 and T3. A schedule S is cascadeless if the transaction in the schedule reads only the data item that were written by committed transaction. Cascading rollbacks will not occur in cascadeless schedule since it reads committed data item. Consider the schedule S with 3 transactions T1, T2 and T3. In this schedule, the transaction reads the value of A of a committed transaction. There is no possibility of cascading rollback. Thus, this is a cascadeless schedule. Because there is no possibility to roll back, because each and every transaction there is a commit, so it is automatically updated and it is stored, so no need to go for a rollback.